Okay, continuing with our review. How long does it take an investment of $1,000 to double in value if it is invested at 8% compounded monthly? Well, let's look at this work. Okay, so we have $1,000 needs to double. So I know my formula is A of t is going to be equal to P times 1, right, plus, or because it's compounding, it's going to be 1 plus R over N raised to the N times T. If I'm monthly compounding, N is equal to 12, R is equal to 0.08, P is equal to 1,000, that initial amount. So I want to know how long it takes to double in value. So $2,000 needs to equal 1,000, right? 1 plus 0.08 divided by 12 raised to the 12 times t power. That's my setup. On my calculator, can go to home, go to my equations, and set in the equation. So 2,000 is going to be equal to, right, 1,000 parentheses 1 plus 0.08 divided by 12, close parentheses, but make sure that we have it closed correctly. And that's going to be raised to the 12 times power. And I'll go ahead and change this to a t because I can. And say, let me solve that equation. And it tells me that my solution is approximately 8.7 years. All right, if I want to give it to one decimal place. How would I do this without a calculator, or with a calculator but without the solver? If you have a calculator that doesn't have the solver, well, I know if I divide both sides by 1,000, all right, divide both sides by 1,000, that means that 2 is going to be equal to something raised to the 12t, right? And what is 1 plus 0.08 divided by 12? That's 1.0067, right? So I have 1.0066, right? And really it's a repeating 6. And so I could say 1.0067. And in order to solve this, I could come in and say, let me take the natural log of both sides. And if I did the natural log of both sides, that would tell me that the natural log of 2 is equal to 12t times the natural log of that 1.006 repeating. And all I would need to do then is use my calculator to solve for t and say, hey, t is going to be given by that natural log of 2, right, divided by 12 times that natural log, and I'm just going to use answer because it's 1.0667, and you'll notice that we get that same value of approximately 8.7 years, right? But the exact value would be the natural log of 2 all divided by 12 times the natural log of 1.0067 approximately. Okay, so that's solving to figure out how long it takes to double. All right, what about if I want to triple in value and my compounding is quarterly? Well, let's see how this would work. I have, all right, an initial investment of 750. I want it to triple, so I need 3 times 750 to be equal to 750. 1 plus 0.036 compounded quarterly is going to be 4 quarters in a year. 4 times t, that I'll have, right, four quarters each year. And then once again, go to my equation solver, enter in my equation. So 3 times 750 is going to be equal to 750 times 1 plus 0.036 divided by 4. All right, make sure my parentheses are correct. Make sure I raise to the correct power. I like to use t if I'm dealing with time. And let it solve. And it tells me that t is approximately 30.7 years. Once again, if I'm rounding to the nearest decimal. If I was going to solve by hand, right, the information that I would need 1 plus 0.036 divided by 4, which happens to be 1.009. So if I was going to solve by hand, I would be able to say that 3 needs to equal 1.009 raised to the 4t. If I take the natural log of one side, I can take the natural log of the other side, and so that would give me the natural log of 3 is equal to 4t using properties of logarithms, so 4t times the natural log of 1.009, and that means that t would be equal to the natural log of 3 all divided by 4 times the natural log of 1.009. And if I had a calculator, I could easily compute that. Natural log of 3, close parentheses, all divided by 4 times the natural log, and I'll just use answer so I don't type it incorrectly, and we see that approximate value, once again, of the 30 point, let's say we wanted 3 decimal places, I'd say 30.654 years. Okay. Continuing, Allison originally purchased her car for a given amount. It's currently valued at a given amount, the average rate of depreciation. So I'll notice now this is with depreciation, right? So value's going down is 16%. Determine the age of Allison's car, right? So our depreciation equation is A of t is going to be equal to my principal amount, 1 minus my rate, raised to the number of years that I have. Right? In this case, my rate is equal to 0.016, not 0.016, excuse me, 16% is just 0.16, and my principal amount is that $45,000. So how long will it take? I want to figure out, right, how long it took to get to 36,520. So 36,520 needs to equal 45,000. 1 minus 0.16 raised to the t power. With the equation solver, once I have my equation set up, 36,520, right, is equal to 45,000. Make sure I have enough zeros. Parentheses 1 minus 0.16 because I'm going down in value when I'm depreciating, and once again raised to the t power. Okay, and if I go to solve, it tells me that, right, t is approximately 14 years. Now, if I double check this, 14 years seems like a long time, and notice we say, oh wait, we had a mistake. That's fine, right? That 14 years feels like a long time to depreciate to 36,000, and that's because we missed a 6 in there. So it makes quite a bit of difference, right? So we recorrect our equation and we go to solve and we say, t is approximately 1.198 years if I'm going to go to 3 decimal places. Right. A quick check that's nice is that we can say, hey, 1 minus 0.16 is 0.84. So saying we're going to be 84% of the value each year. So if I have $45,000 times 0.84, that gets me down to $37,000 after 1 year, times 0.84, that gets me down to $31,000 after 2 years, which would have let us know, hey, it needs to be somewhere between 1 and 2 years. All right. If I was going to solve this by hand, all right, if I was going to solve this by hand, I could divide both sides by the 45,000. All right, divide both sides by the 45,000. So I've got, all right, let's do it this way. There we are, 36,520 divided by 45,000 needs to equal 0.84 raised to the t power, right? If I take the natural log of one side, I can take the natural log of the other side. Properties of exponents, that tells me that the natural log of 36,520 divided by 45,000 must be equal to t times the natural log of 0.84. So therefore, t is equal to that natural log of 36,520 divided by 45,000 all over the natural log of 0.84. All right, so let's go ahead and make that computation. Natural log 36,520. Make sure I have it correct. 45,000. Make sure I have it correct. All right, close my parentheses, then divide natural log of 0.84. Close my parentheses, and I see that value set up the same. So that is working with the finance and with depreciation, working with quarterly compounding, solving equations. In the next video, we're going to talk about solving equations involving logarithms and exponentials.